Hi, I'm Virginia García and I'm going to talk about routing. Host forwarding decision. Another role of the network layer is to direct packets between hosts. A host can send a packet to itself by pinging a special IPv4 address known as the loopback interface local host, which hosts on the same network as the sending host, and remote host, which is the remote network. Whether a packet is destined for a local host or a remote host is determined by the IP address and subnet mask combination of the source device compared to the destination device. In LAN or WLAN devices are interconnected using an intermediate device that provides interconnection between local hosts. If a host is sending a packet to a device that is configured with the same IP network as the host device, the packet is simply sent directly through the intermediate device to the destination. Default gateway. The default gateway is a device, often a router, which manages the traffic from the local network to devices on remote networks. The local table of the host typically contains direct connection loopback interface address, local network route, host directly connected, and local default route, which represents the route that packets must take to reach all remote network address and is the IP address of the network interface of the router that is connected to the local network. IPv host routing table. On a Windows host, the route print or netstat_r command can be used to display the host routing table. Entering one of these commands displays three sections related to the current TCP IP network connection. Interface lists are the MAC address and assigned interface number of every network capable interface on the host. IPv4 route table lists all known IPv4 routes, including direct connections, local networks, and local default routes. IPv6 route table lists all known IPv6 routes. The figure displays the IPv4 route table section of the output. Notice that the output is divided into 5 columns which identify network destination, lists the reachable networks. Net mask lists a subnet mask that informs the host how to determine the network and the host portions of the IP address. Gateway address used by the local computer to get to a remote network destination. If a destination is directly reachable, it will show as on link in this column. Interface address of the physical interface used to send the package to the gateway that is used to reach the network destination, and finally the metric, which lists the cost of each route and is used to determine the best route to a destination. Host routing entries are the destination networks that can be grouped into 5 sections as identified by the highlighted areas in the figure. 0000 are the local default route. That is, all the packets with destination that do not match other specified address in the routing table are forwarded to the gateway because they are remote networks. 127.0.0.0 to 127.250.215, 55.55.55. These loopback addresses all relate to the direct connection and provide service to the local host. 129.168.10.0. The local network root address represents all computers, and 192.168.1a.10 network. The 192.168.1 168.10.10, the address of the local host, and 192.168.10.255 are the network broadcast addresses, which sends messages to all hosts on the local network route. And the 224.0.0.0 are the special multicast class addresses reserved for use through either the loopback interface or the host IP address. And finally, the 255.255.255.255 are the last two addresses represent the limited broadcast IP address values for use through either the loopback interface or the host IP address. These addresses can be used to find a DHCP server before the local IP is determined. Sample IPv6 host routing table. The IPv6 route table section displays 4 columns which identify: if lists the interface numbers from the interface list section of the net-stat-r command. The interface numbers correspond to the network-capable interface on the host, including Ethernet, Wi-Fi, and Bluetooth adapters. Metric lists the cost of each route to a destination. Lower numbers indicate preferred routes. Network destination are the least reachable networks. And finally, gateway lists the address used by the local host to forward packets to a remote network destination on link indicates that the host is currently connected to it. The IPv route section reveals the following network destination. This is the IPv6 equivalent of the local default route. This is the equivalent to the IPv4 loopback address. This is the global unicast network prefix. This is the global unicast IPv6 address of the local computer. This is the local link network root address and represents all computers. This is the link local IPv6 address of the local computer. And finally, these are a special reserved multicast class D addresses equivalent to the IPv4 224.x.x.x addresses. Router packet forwarding decision. When a host sends a packet to another host, it will use its routing table to determine where to send the packet. If the destination host is on a remote network, the packet is forwarded to the address of a gateway device. When a packet arrives on a router interface, the router looks at its routing table to determine where to forward the packets. Directly forward or forward it to default gateway. The routing table of a router stores information about directly connected routes, which are routers at a directly connected route when an interface is configured with an IP address and is activated, odd or remote routes. These routes come from remote networks connected to other routers. Routers to these networks can either be manually configured on the local router by the network administrator or dynamically configured by enabling the local router to exchange routing information with other routers using dynamic routing protocols. The routing table of a router is similar to the routing table of a host. They both identify the destination network, metric associated with the destination network, and the gateway to get the destination network. Route source. The route source is labeled A in the figure. It identifies how the route was learned. Directly connected interfaces have two route source codes, C, L, and S. C identifies a directly connected network automatically created. L identifies that this is a linked local route automatically created, and S identifies that the route was manually created by an administrator to reach a specific network. This is known as static route. There are other codes. The destination network identifies the address of the remote network, and the outgoing interface identifies the exit interface to use when forwarding packets to the destination network. Remote network routing table entries. The same routing table shows the information about the connection with remote routers and displays this information. Route source identifies how the route was learned. Destination network identifies the address of the remote network. Administrative distance identifies the trustworthiness of the route source. Metric identifies the value assigned to reach the remote network. Lower values indicate preferred routes. Next hop identifies the IP address of the next router to forward the packet. Route timestamp identifies when the route was last heard from. An outgoing interface identifies the exit interface to use to forward a packet toward the final destination. Next hop address. A next hop is the address of the device that will process the packet next for a host on a network. The address of the default gateway is the next hop for all packets that must be sent to another network. In the routing table of a router, each route to a remote network lists a next hop. A next hop router is a gateway to remote networks. Networks directly connected to a router have no next hop address because a router can forward packets directly to hosts on these networks. Routers. A router is a computer. There are many types of infrastructure routers available. In fact, Cisco routers are designed to address the needs of branch, WAN, and service provider. Routers also require operating systems, central processing units, random access memory, and read-only memory. Router memory. A router has access to 4 types of memory. RAM, which is used for running IOS, running configuration file, IP routing, and ARP tables, and packet buffer. ROM, which stores boot up instructions, basic diagnostic software, and limited IOS. NBRAM, startup configuration file, and flash, iOS, and other system files. Router backplane and connection. The backplane is consisted by console ports, 2 console ports for the initial configuration and command line interface management, aux port, which is used for remote management access to LAN interfaces, here and here, and high-speed WAN interface card slots, which provides modularity and flexibility by enabling the router to support different types of interface modules, storage slots to support expanding capabilities, dual compact flash memory slots, and 2 USB host ports for additional storage space. And the connection is composed by management ports, which are the console and auxiliary ports used to configure, manage, and troubleshoot the router. In-band router interface, LAN and WAN interface configures with IP addressing to carry user traffic. The router boots up. Cisco IOS for routers provides the following: addressing interfaces, routing security, QoS resources management. A router loads the following two files into RAM when it's booted. iOS image file facilitates the basic operation of the device's hardware components, and the startup configuration file, which contains commands that are used to configure and route and create the running configuration file stored in the RAM. And finally, the router boots up process, which is to perform the post and load the bootstrap program, locate and load the Cisco iOS software, and finally locate and load the startup configuration file or enter setup mode.